Session is now live on YouTube. I'll just be sharing my screen. I hope my screen is clearly visible. Okay. Okay, I'm starting the webinar now. Good afternoon, everyone. Thanks for joining us for today's session on the impact of 5G and V2X on connected vehicles. This session is brought to you by the team at India's leading automotive events, Commercial Vehicle Forum, Two-Wheeler Forum, and Passenger Vehicle Forum, or as you are more popularly known, CVF, TWF, and PVF. My name is Rohit Dewan, and I'm the event director for these forums. So before we begin today's session, I just wanted to take you over the agenda for the session. First, I will be starting off with a brief introduction. Post the introduction, there will be a presentation of around 30 minutes by Mr. Fumitaka Kubota, who works in automotive marketing at Anritsu Corporation, Japan. Once the presentation is concluded, I will be introducing the speakers and moderator for today's session. Our moderator will then give a quick overview of our session for today, and then will initiate the discussion that will last for about an hour. And post the completion of the session, we will have a Q&A segment of around 10 minutes towards the end of today's session where the audience can share, audience's questions will be addressed. Your active participation is essential to make this session a success. Right now, we have everybody in listen mode, but here is how you can interact with us. You can ask us questions. At the bottom of the screen, there is a Q&A box. Please feel free to send us your questions in the Q&A box. We will take those questions in the Q&A segment at the end of the session. You can also choose to upvote these questions. This will help us in addressing the most burning topics. We also invite you to share insights in the poll questions that we will be flashing regularly on your screen at regular intervals. Do note that we also have this session streaming live on YouTube, and anyone who has registered for the session will also receive a recording and presentation post the completion of the session. Apart from that, I request you to share your insights in the feedback form that will open as soon as you exit the session. If there's something you're interested in learning more about this after the session, please feel free to reach out with us. I wanted to now take this time to especially thank our partner Anritsu for supporting the session. Anritsu Corporation is a Japanese multinational, which is a leader in test and measurement to support advanced automotive technologies such as self-driving vehicles and connected vehicles. Anritsu is a global pioneer, and that is due to its comprehensive experience in leading-edge wire-to-wireless measurement technologies, including the evolution and implementation of 5G. It's more than 120-year-old history in radio applications with a wide product line covering optical, transmission, wireless, and protocol fields. It also has a great reputation for providing flexible and responsive service and support to its global customers. And now, to shed more light on Anritsu and some of the interesting innovations they've been working on, I would like to invite Mr. Fumitaka Kubota, who works in automotive marketing at Anritsu Corporation, Japan, to share his insights. Mr. Kubota has been working with Anritsu for more than 20 years and has a varied experience working with automotive customers globally, especially with the Japanese customers. He will today talk about the trends and technique in 5G and automotive electronics testing. So over to you, Kubota-san, to take it forward.
Hello everyone, my name is Fumitaka Kubota, marketing expert of Anritsu based in Japan. Today, I would like to talk about automotive industry in a 5G era. I will cover following contents today. First, company profile. Second, automotive trend. Third, automotive telematics test. Fourth, eco test. And last, other automotive test use cases. My presentation is about 30 minutes and then total 43 slides. I would like to quickly introducing who is Anritsu and what Anritsu do. Anritsu Corporation headquarters is in Atsugi, Japan, which is about 50 kilometers west of Tokyo. 125 years long history company. This picture is our headquarters building where I'm speaking from. We have sold 107 billion Japanese yen, which is about 1 billion US dollar last year, 2020. Majority, 70% of business is coming from test and measurement segment. Within test and measurement, more than 22% of business is coming from outside Japan. Automotive business is including to this. Anritsu business segment looks like this. Upper part is test and measurement company. It is covering many kinds of communication tests such as from optical fiber wire test solution to wireless mobile test solution. Let's move on to the automotive 5G trend topic. Automotive industry have a long history. The first mass production car was released in the beginning of the 20th century. 100 years later today, communication technology start equipping to the car. The new trend of connected car, autonomous drive vehicle development began. To realizing these, 5G communication is very important technology. The lower right graph. This is very famous Ericsson mobility report publishing every year. This graph is a subscriber number of each 2G, 3G, 4G, 5G technology in the worldwide and how it growing to change in the future. In 2019, orange color 5G service started. As you can see, that green color 4G LTE is still majority in the next 10 years. 5G is growing. Let's take a look from market trend. Automotive is second line. Level 3 car release started from leading car manufacturer. 5G TCU, telematics control unit development race has started recently. Some of the leading car manufacturer OEM and TCU Tier 1 component vendors are already start investing for 5G TCU development. From technology roadmap, red color star in the upper side is Tokyo Olympic game in 2021 this year, which is just started from last week. 3GPP standard is green in its green color part. Release 16 work item, which is including 5G NR new radio spec, is going to be fixed by the end of this year, 2021. After release 16 specs fixed, then usually the leading chipset vendor start developing the release 16 supported 5G chipset and going to release it within few years time frame. Once release 16 supported chipset ready, Tier 1 vendor will release 16 supported 5G TCU accordingly. The next step is Release 17. Release 17 specification is currently under discussion at 3GPP. Let's talk about the major difference between Release 16 and Release 17 in this slide. EMBB, red color, is mainly improving the data speed. In Release 16 EMBB, millimeter wave CA, carrier aggregation, will be supported. Then, frequency extension to above 52.6 GHz is planned in Release 17. So EMBB is very important for sending large file data, such as, for example, corner camera image data from mobile network to vehicle, etc. URLLC, second one, is mainly improving the communication latency. This part is one of the key parts for automotive industry. In Release 17, it says straightening, side link, direct communication between devices. In another word, this is vehicle-to-vehicle direct communication enhancement. This slide and the next slide is sourced from US leading chipset vendor Qualcomm open information. And these slides also explain the overview of what Release 16 and Release 17 can do. As you can see that these technologies are also very important for the connected car and future autonomous drive car. (6G). It is maybe a little bit early to talk about 6G, but this is a kind of a frequently asked question recently. So I quickly introducing this. As you can see, the upper left blue color circle. This is 6G target spec. There is a blue color triangle in the 6G circle. This is the current 5G target spec. So you can compare these. Most key part is 6G data rate, which targeting more than 100 gigabit per second, which is more than 5 times faster than the current 5G target 20 gigabit per second. Anritsu is also joining to the industry discussion as a global test and measurement company. This slide showing cellular V2X service infrastructure and vehicle overview. Red color is showing side link, which is direct communication, such as vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure, such as roadside unit. Blue color is showing V2N, vehicle to network. What is new in the V2X? It is side link red color part, because V2N, vehicle to network, it is like existing smartphone to base station current mobile network operator business model. But there is no smartphone to smartphone direct communication existing today. So 5G side link is new area of the future challenges. Currently, V2N, vehicle to network development is progressing faster than side link development. Now, I would like to talk about automotive telematics test. This is the most important test for connected car development. Carrier aggregation. This is one of the very typical telematics tests. 5G carrier aggregation become more complex than 4G LTE carrier aggregation. Bandwidth expansion by carrier aggregation is basis for high-speed communication that supports 5G telematics Day 1 services. As you can see in this slide, there are many patterns of the carrier aggregation in 5G. In many cases, packet connection failure occur due to the specific band. And comprehensive verification of the band combination supported by the in-vehicle devices is effective. Cell mobility. This is another typical telematics test. As you can see the picture, there is a blue color car moving in different base station cell area. This is called cell mobility. As wrote on the top of this slide, the cell mobility test, which simulate multiple cell, is most important index in the automotive use cases. There are a wide variety of combination patterns such as 3G, 4G, 5G, intra switching, carrier aggregation, and ENDC connections. It is necessary to use network simulator to perform stable cell mobility test. This slide shows two examples of cell mobility test. First one is instantaneous interruption, reconnection. Second one is access restriction. First one, instantaneous interruption, reconnection. Tunnel of the road is very typical case. When you're driving a car, then enter to the tunnel, which does not have cellular network repeater equipped. Your car will not receive any signal from the base station. As you can see, the above picture, upper picture, your car TCU reception power going to be decreased, then out of service when start enter to the tunnel. Your car TCU reception power going to be increased again from another base station when tunnel section finish. This is called instantaneous interruption reconnection. Second one is access restriction. Please take a look at lower picture. When the disaster occurs, such as earthquake or big events such as firework display, where big crowd of people in the same base station coverage, network side start restricting the access to the general user, including car-mounted TCU. This is access restrictions. This is to avoiding the system down. Access will be prioritizing to the emergency calls, disaster message board, etc. Simulator is the right tool to test this, as an access restriction cannot be reproduced anytime in the field. Roaming. Problems related to the roaming are a very typical field issue. Please take a look at the picture. You are driving a car in Europe. It is long distance and crossing several countries' border. For example, if you are crossing the border from France to Germany, MNO, mobile network operator service, will be handing over from French carrier to German carrier as described in the picture. Please take a look at the lower side. Green color French carrier downlink power decreasing when crossing the border. Blue color German carrier downlink power will be increasing after roaming handover. This is roaming. TCU roaming fail is one of the major claims from car user customer to the car manufacturer. So an effective approach is to continuous test that repeat connectivity to multiple network and state transitions. 5G have a new technology called network slicing. This is multiple PDN communication with multiple application server. Please take a look at the picture. Green color word right hand side says network slice number 1 browser, network slice number 2 streaming, network slice number 3 voice, In a EPC, one mobile device is connected to only one SGW. But in the 5G, one mobile device is connected to multiple SMF. It can be connected to UPF at the same time. It is possible to use network according to each service that has different requirements such as bandwidth and QoS. With network slicing, it is possible to use multiple slices properly with the one mobile devices. Voice communication. In 4G LTE, VoLTE, voice over LTE, is used in the network. Left picture is showing 5G NSA service. In a 5G, 4G LTE based VoLTE is still used in the 5G non-standalone services. Middle picture is showing early phase of 5G SA service. 5G VoNR, voice over new radio, is not supported. Right picture is showing 5G service. 5G SA service start from this year. 5G voice service, VoNR, is starting. TCU require to test this VoNR from this year. Throughput. This is a very typical telematics test. Maximum throughput is an important index in evaluating the integrated performance of the hardware and software. When evaluating the stress tolerance, heat generation, and current consumption of the processor, it is necessary to carry out the maximum throughput state. Anritsu base station simulator can generate IP packet with the built-in hardware. It is possible to build a stable throughput measurement environment regardless of the performance of the external PC. It also provides a display a variety of information to evaluate and analyze throughput. End-to-end data communication verification. Leading car manufacturer providing data communication service to car users. It is important to test end-to-end data communication verification to keep the quality high. Please take a look at the picture. Left side is car-mounted TCU or dashboard. Right side is back-end service, which providing application service. This enabling telematics service level operation verification. Using SMS for waking up TCU. Message verification for HTTP and MQTT data communication, so on. This slide showing key verification in 5G TCU development. And it have many different testing solutions for 5G TCU. These tests are all included in the telematics test area at the car manufacturer, OEM, TCU, module tier 1 vendor, tier 2, and even test house, so on. In earlier slide, I have mainly talked about 5G telematics test, which is upper left one in this slide. And let's have other testing solution as well. From upper right, infotainment tests such as Bluetooth, Wi-Fi test. Lower right part, there is a car radar test, Ethernet cable test. And then lower left part, this is a cellular V2X test. This slide showing Anritsu's very strong 5G testing solution portfolio from chipset R&D to UE device mass production. Anritsu has long history for contributing UE testing solution, which is ready to supporting automotive industry as well. This slide is an example of Anritsu news release which is showing how Anritsu contributing to 5G device development. Anritsu also keeping the leading position in the industry for 5G certification area, as you can see from this news release. "5G NR device development become more complicated than 4G LTE, especially so many band combinations. Anritsu providing automated testing solution so that 5G NR many band combination issue will be solved in the 5G telematics test. Anritsu automated testing software enable full coverage performance tests without high skill in a mobile communication, so that this software can reduce automotive engineer workload. Now I would like to talk about eCall test. This is not 5G, but this is another key test in the automotive industry. First, I will explain the background behind the introduction of eCall. When we invented the car, it is possible to go faster and go far away than walking by foot. On the other hand, the number of traffic accidents is increasing, and unfortunately, the number of people dying from the traffic accident is increasing all over the world. This slide shows a road fatality rate per 100,000 people in each country. Sorry, I don't have data for India. How to reduce this traffic accident deaths is an issue and social demand. Looking at the deaths from the traffic accident, there is an instant death, but it also includes lives that were lost immediately after the accident, even though they were alive because they could not save their lives in time. This saving life is an eCall that I will explain. It is a mechanism to quickly rush rescue assets such as ambulance, fire rescue vehicle, doctor helicopters, and police to the accident site. The eCall service has been launched and is being considered for introduction around the world. Now let's talk about how eCall works. Number 1, emergency call. Emergency call is made automatically by the car as soon as onboard sensor register a serious accident. By pushing dedicated button in the car, any car occupant can also make an eCall manually. Number 2, positioning. Via satellite positioning and mobile telephony caller location, the accurate position of the accident scene is fixed and then transmitted by the eCall to the nearest emergency call center. More information is given in the eCall, the direction of the travel and the vehicle type. Number 3, emergency call center. The eCall urgency is recognized. The accident's location can be seen on the screen. A trained operator tries to talk with the vehicle occupant to get more information. If there is no reaction, emergency service are sent off without delay. Number 4, quicker help. Due to the exact knowledge of the accident location, the emergency service, ambulance, firefighter, police arrive much quicker at the crash site. Time saved translates into lives saved. The upper half of the picture in this slide is the actual environment introduced in the previous slide. If you replace this with the test environment, it will be the lower half of the picture in this slide. At the lower left is a GNS simulator. This is a simulator that simulates navigation positioning satellite. Any location information can be sent. The IVS in the second black color box at the bottom left is an abbreviation for the in-vehicle system, which is an eCall onboard unit installed in the car. The third cellular network simulator from the bottom left is a simulator that simulates a mobile phone base station. It supports 2G, 3G, 4G commercial communication standard around the world. The fourth laptop in the lower left is a laptop with software that simulates an emergency call center called PSAP Simulator. It is possible to perform a location information data reception test sent from the IVS eCall onboard unit of the accident vehicle, and conversely, a call test from emergency call center side to the IVS eCall onboard unit. This test environment can be used for eCall device development for automotive manufacturer in a vehicle device and in-vehicle devices manufacturers. It can also be used for eCall legal certification test in each country. Next, I will explain the status of an eCall initiative in each country. It is roughly color-coded into 4. Orange color is European standard eCall and the eCall of the country that fall into this category. Brown color is a group of Elaglonas of Russian standard eCall. Light blue is a UN standard eCall group. Green is eCall for countries that have their own standard. First, let's talk about the first orange eCall in Europe. Mandatory started on March 31st, 2018. Originally, it was planned to start the earliest in the world, but as a result, it came after Russia. The target area is EU member states. The network standard is used are 2G, GSM, and 3G WCDMA. In urban area of the Europe, 4G LTE is common in a mobile phone base station network, but since 2G GSM radio wave are still used in a depopulated area and mountainous road in Europe. eCall tests based on 2G GSM standard are still required. Green color category. As you can see, India eCall in the 4th and 5th part. The release plan schedule for India eCall are different depending on the vehicle type. The first group is public transportation such as bus, taxi. The second group is ordinary car. The release date has not been decided yet. In Europe, they have a new plan to introducing energy eCall. This is next generation eCall using 4G LTE technology. The difference between NG eCall and the current EU eCall is 2G, 3G eCall is based on circuit switch network, but 4G packet data based IMS transmission. Since the energy eCall using 4G LTE technology, which can carry more data than 2G, 3G, using this big advantage, future enhancement shown in this slide is under discussion in Europe now. Energy eCall specification is defined in RFC 8147 document, and Europe have a plan to introducing this energy eCall service from 2024 timeframe, but this still not fixed yet. And then, since from eCall point of view, 4G LTE is still future item. So this is totally different from the current 5G telematics discussion. So please be careful about the different speed between the different development speed between eCall and telematics. This is the last section. I would like to talk about other automotive use case tests. This is the introduction of our new activity. Anritsu is now working with leading hill simulator vendor called D-Space Germany. We jointly made an unparalleled integration of 5G network emulator in a hardware-in-the-loop hill system to develop next-generation automotive application for connected vehicle. It is with virtual test drive for end-to-end testing of vehicle to infrastructure V2I application for traffic optimization and sensor sharing, all powered by realistic simulation of the vehicle and the environment with smart infrastructure as well as real 5G communication. The combination of 5G and edge cloud, which promise high data throughput and low latency, has a potential to allow for completely new applications, such as sharing raw sensor data with vehicle and infrastructure. This can enable cooperative perception, swarm intelligence based on the shared AI, or real-time traffic optimization to make automated driving even safer, more comfortable, and eco-friendly. However, without a suitable 5G testbed infrastructure, the development of associated application can be challenging. This is to showing the example of the testing. Upper picture, simulation map. One 5G NR antenna is in the city area, and the other LTE antenna is in the local area. The vehicle runs on the road between the antennas. Lower side picture, simulation situation. The vehicle communicates with the two antennas and NR handover works fine, displaying the view of the invisible scene. This system integrates the Anritsu radio communication test station MT8000, an all-in-one 5G radio frequency, functional, and protocol test solution, with the D-Space Scalatio real-time system for demanding hill simulation or rapid prototyping. For realistic test of V2X devices and application, Scalatio is complemented by the simulation of virtual test devices with D-Space Automotive Simulation Model, ASM. Open Simulink model for simulating the vehicle and environment such as road, traffic, and infrastructure. In addition, dedicated software interface was developed to connect the Anritsu test station and control the 5G mobile data link to the back end during real-time simulation. This is end of my presentation. As a summary, it is true that 5G technology is complex, but don't be afraid. 5G test and automotive communication test expert Anritsu is here and can assist you in your success. Thank you very much. ありがとう。
Thanks for the insightful presentation, Kubota-san. Now moving on to the panel discussion, I would like to briefly introduce our expert speaker group. Our first panelist for the day is Mr. Sirish Bachu, Managing Director, Danlo Technologies, India. Sirish is an industry veteran with almost 3 decades of rich working experience across the automotive and IT industry, especially in the OEM and EV segment in India. He has previously held leadership roles involving strategy, business, and R&D, and has been associated with several firms including Bosch, Mahindra & Mahindra, and Ather Energy. Our next panelist for the session is Mr. Vinay Solanki, who is Head of Digital Solutions and General Manager at Napino Auto and Electronics Limited. Vinay has over 16 years of experience in business development, strategy, partner management, sales and technology management within domains such as IoT, digital transformation, Wi-Fi, fintech, and web. He has exposure to a variety of industries such as technology with Lenovo, telecom with Airtel, machine to machine with Aries Communication, and investment banking with Goldman Sachs. Also, he is the founder of the third largest IoT community called IoT NCR with 8,000 plus members, and is recognized as one of the global top 20 thought leader in IoT and analytics by Thinkers 360. Moreover, he's a TEDx speaker and member of NASCOM, DOT Tech, as well as an author on Your Story, EFI, IoT Central, and International Media. Our third speaker for the session is Mr. Santosh Datta, who is lead engineering, product area connectivity at Robert Bosch Engineering and Business Solutions. Santosh has over 18 years of cross-functional experience across various geographies and auto sector, with a special emphasis on electronics control units, automotive system engineering, and connected mobility solutions. In his current role, he's responsible for product management and strategy for telematics and connected mobility solutions in India. Being an automotive technology generalist, he loves working with different partners in mobility ecosystem to realize the benefits of connected mobility through various technologies such as 5G and V2X. Next, we have Mr. Shantanu Davare, who presently heads the infotainment telematics organization in EIS or automotive at TCS. Shantanu has been working with TCS for the past 17 years in the automotive domain and has played multiple roles ground up in terms of developer, architect, project leader, and group leader. He has experience building huge teams in infotainment and telematics around design, development, and validation. Our final panelist for the session is Mr. Sridhar Reddy. Sridhar is responsible for product management of the V2X Automotive Solutions within the Connected Infrastructure Strategic Business Unit at Harman. In his current role, he works with various OEMs, telecom, and other verticals to shape the evolution of Harman V2X products. He has spent 10 years in the V2X field as part of Savari Inc., a leader in V2X, where he was responsible for both India R&D sector as well as drove product evolution. He has worked with a vast variety of ecosystem partners, vendors, and customers, ranging from consortiums such as US.com to semiconductor companies to global automotive OEMs. He joined Harman as part of an acquisition of Savari. Before Savari, he spent close to 15 years in different companies in the Bay Area. That was in various roles in telecom, semiconductor companies, specializing in multi-service across platforms. He holds a BE from RVCE Bangalore and an MS in CS and Telecom from University of Missouri, Kansas City. Finally, we have a moderator for the session. I would like to welcome him, Mr. Ashim Sharma, who is the partner and group head, business performance improvement at Nomura Research Institute Consulting and Solutions. After completing his BTech with honors in mechanical engineering from NIT Hamirpur, Ashim started his career at Mahindra, wherein he worked with the core team that launched the new Mahindra Bolero. Thereafter, he went to do his MBA at SP Jain, and he currently leads the business performance improvement group of NRI Consulting in India, and has been with the firm for 6.5 years. Most of his work has been in the areas of overall business strategy, new product development, technological readiness, innovation readiness, scenario planning, market entry, cost reduction, project management, and organizational restructuring. Ashim has also developed thought leadership in the area of scenario planning, alternative automotive powertrains, modularity, mass manufacturing, new forms of mobility, engineering sources outsourcing, to name a few. Over to you, Ashim, to take it forward.
Thank you, Rohit, for that introduction and also for introducing to us all the panelists. And it's a very good afternoon to all of you. I think, when we talk of the word connected, it's only become much more relevant in today's situation where COVID-19 has forced many of us into a bit of isolation, or let me call it self-isolation. And therefore, avenues to stay connected are becoming more and more important, whether it's looking at our smartphones today or also looking at vehicles, which, as we all know over here, have evolved at a fast pace, and they are no longer just an assembly of mechanical components, but are fused with cutting-edge technology in the form of software systems, which can also interact with surroundings. In addition to that, we're also seeing that with the advent of smart cities, infrastructural elements, whether it's buildings, traffic signals, parking spaces, have also started communicating with each other as we strive to become more efficient and prepared for a sustainable future. And this is where vehicle to everything, that is V2X, is probably at the epicenter of this kind of transition that is happening and will be driven by our advancement in communication systems, in hardware, software devices, as well as the overall infrastructural readiness. Therefore, it's only very much relevant that today we have an august list of speakers here to talk about this very pertinent subject on 5G communication system and how it will augment our efforts in becoming future ready as far as the connected vehicle ecosystem is concerned. So with that, once again, a very warm welcome to all the panelists as we kickstart this panel discussion. Maybe to start the proceedings for today, I would like to start with Mr. Salanki, and the question to you, Mr. Salanki, is, for a vehicle to communicate with an entity, that entity must also be equipped with V2X technology. And based on our hypothesis of 5G adoption becoming more and more mainstream in the country, how long do you think it will take for V2X technology to come into mainstream applications in a large manner in the country?
Sure. Thank you, Mr. Ashim. I'm audible?
Yes, very much.
Great. So first of all, thanks to Rohit and to the forum for giving this opportunity to share our thoughts here on this a very important topic, V2X. And if you look at V2X, right, V2X means a vehicle should be able to communicate with anything or everything around it in order to make the driving safer. That is one of the target. And then there are many other applications or use cases or value addition that we should bring to the table with V2X. Now, V2X means it should be able to talk to other vehicle infrastructure. It could be the railway crossing or a traffic signal or a toll booth. It should be able to talk to other devices on the road or near the driving area or location, or maybe even the network, right? Or could be other things as well, like talk to the animal crossing the road in India, right? Can I talk to the cow who's crossing the road and find it, or maybe at least detect it, right? Or while I'm on the highway, I think that where the speed is really high, can I communicate faster and in a more efficient way with typical things like something crossing abruptly or a sharp turn or a U-turn area. So giving those kind of indications that, and today I think we use other mechanisms to, as a driver, to arrive at those conclusions that a U-turn is coming, maybe I should slow down, or a traffic signal is coming and I see yellow and I slow down, right? So to answer your question, vehicles are already getting equipped with technology. I think we heard that from other speakers since in this forum today. There is already 5G being talked about, where can we enable a vehicle with a 5G connectivity and deploy the 5G network, right? Or maybe the other network like 4G. But as you said, I think it is absolutely right that if vehicle to anything or everything has to become efficient or mainstream, the key infrastructure such as putting the right connectivity in this modules like a toll booth or a traffic signal or anything else is important. Number one. Are these devices already getting connected? Yes, they are. In India, to a certain extent, outside India, I think I have seen as I've traveled that the traffic signals or even some other specific parameters or indication of safety parameters or standards are throwing some kind of a data through sensors to the network. Especially if you think of self-driving autonomous car. Look at what California has done, or look at some other areas across the world where an autonomous car cannot drive if it is not able to communicate, number one, with almost everything that is required to be communicated and fast enough with all efficiencies required. So I don't know how long it will take, to be honest. I don't have that answer, whether it will be like in the next 5 year or next 10 year. But I think the evolution of 5G as a technology is picking up pace. We have already seen other technology like in IoT segment, like NB IoTs is, for example, is coming up, right? Do I need 5G every time? The answer is yes and no. I need 5G for high broadband, high speed communication. When a camera is talking to my car, right, and sending me the image, and hence the intelligence to the car that there is an accident around 2 kilometers from now, you start slowing down, or there is a diversion, right? Then I need a high-speed one. I think personally, I may be wrong here, that many other communication doesn't need that high bandwidth. I can use NB-IoT, I can use 4G, I can use some other protocols or standards of connectivity for it to communicate with a car efficiently. So that's my answer. But I hope that V2V should become mainstream first, because vehicle-to-vehicle communication is ultra important, and then other infrastructure, other standards, devices, network, and so on can start onboarding in subsequent fashion. Because if my car can talk to at least to the vehicle around me, whether two-wheeler or four-wheeler, I think that will add a lot of value addition to in terms of safety, in terms of other aspects, right? Especially tailgating or a blind spot. When there is a bike coming on a blind spot, one of the major cause of accidents in India that we have seen can be a very efficient use. Thank you.
All right. Thank you, Mr. Solanki, for sharing that perspective, and rightly saying V2V and then V2X. That will sort of be the course of this evolution. Just taking that question across to Mr. Bachu also. Would you have any additional perspective to share on this?
First of all, thanks, Ashim. Very good afternoon to everybody. And thanks to Rohit and CVF for also having me on this panel, which is always interesting, good opportunity to learn from other peers in the industry as well. Coming to the question, Ashim, it's like gazing in the crystal ball, what time frame and all those things, that's all speculation. But as the technologies are evolving, right, there are a few things we have to keep in mind in terms of when, as an industry, as a corporates which are doing this solutioning, the factors which would help accelerate bringing these technologies. Okay, compared to, I'll draw the contrast between, say, US or Europe, where things are way ahead in terms of the development as well as the on-the-field applications. Whereas in India, we are still talking in terms of, say, 5G introduction is a very nascent topic yet. The 4G stabilization itself is a big theme right now. And coming to the V2X aspects of it, where we talk about the vehicle to infrastructure, the vehicle to vehicle communications, and so on, we are still looking at the industry leaders or the world leaders to how they are shaping up. And then it is good to learn from others how things are evolving and picking up from those. Now, there are a few challenges on our side is in terms of when we look at a mass rollout. Typically, it would start with a very niche segment of vehicles having these kind of features, because at the end of the day, India as a market is a very cost-conscious market. So only the niche segment can afford. And what value is this cost bringing to the end customer? So that's very, very important to answer. Whereas on the technology front, it's very exciting. It's very very, very engaging to be in this side of the game where you're constantly evolving, constantly finding solutions. And already Vikram spoke about for a same scenario in a vehicle, for a long range communication, you may have to rely on the 5G, but for the near communication, you may not need that. You may rely on the 4G or the NB-IoT kind of stuff. Now, how do you translate this into reality? Because when you're designing a product, do we go for so many multiple options for solving one single, say, contextual awareness aspect of it? Or do we need one solution which takes care of everything? I think that is the key for the proliferation aspect. And as we go ahead, I think how we are integrating all these capabilities into one single solution and also making it cost effective will make a lot of difference of how soon these technologies come into the Indian market. The second aspect of it is, in terms of all these V2X require a lot of infrastructure. And though we are seeing that the infrastructure front, a lot of development is happening in India, especially the highways and then also the quality of the roads and increasing and so on. We are talking of a lot of, say, concrete infrastructure, non-brick and mortar infrastructure, which is to do with more of a traffic signals, more of a intelligent devices being planted at various places along the road and things like that along the highways. And that is where one of the major challenges, what I see is consistency in terms of how these gets implemented in our country. Especially if you look at AIS 140 itself, which started as a very good initiative connecting with the Nirbhaya aspect of it and JNM themes. The way it is implemented is now it is decentralized. Each and every state has its own way of treating it and so on. This becomes a big challenge because there's no standardization, no consistency. And as a product manufacturer, when you want to introduce this becomes a big challenge. I mean, even today, simple things like a traffic signs, what you see on the road, right? For a no entry, same no entry sign, you will find variety of what you call signboards in different cities and different states. So how do we attempt the standardization? I think that topic needs to be addressed along with the technology solution part of it as well.
Right. Yeah. Thanks a lot for that very interesting perspective. I think right from Indian consumer, as we all know, is very, very value conscious. So, it's just not going to have it because it's a fancy solution. It needs much more than that. And also, I think alongside that, this thing about standardization, and I think wherein also harmonization of standards as detailed out in the UNEC, etc., bringing them to India and then using a standard protocol here. I think those will certainly be big cornerstones for this to become more and more, proliferate more and more within the country. So thank you very much. And I think stepping on from that very explanation, we also understand that there are two major technologies at play when we talk about V2X. It's V2X, which is mobile base, and DSRC, the dedicated short range communication. So which one will be more suitable for India and why? And what are some of the global use cases here? If you could comment on that, Mr. Reddy, we could take your perspective on that. And after that, we could also take Mr. Davare's perspective on the same part.
Sure. Can you all hear me first?
Yes, very well.
Okay, perfect. I really apologize. I might, after this specific question, I might kind of try logging off and redialing back in. For some reason, my camera is not working.
But we can see you very well.
Oh, you can? Okay, excellent.
Yeah.
All right. Yeah. Okay. At least I can't see myself. So I guess that's fine. Good afternoon to the panelists as well. I think Vineet touched upon some of these aspects already indirectly, though. His answer about why or how technology would actually get productized and deployed, especially in our country, which is very cost conscious. So coming to the DSRC and CV2X. So if you look at these two competing technologies, DSRC has been around for the last, say, 15 years, right? A lot of activities, probably only in the last 10 years. It's taken a long time for OEMs and DOTs and so on in the West to kind of test it, reach a level of maturity where they feel like it can be deployed and so on. But if you actually look at, I won't call it deal flow, but you look at who actually pays for this, right? What is the main use case? And as Vineet said, I think both Vinay and Vineet touched on this, you need a lot of infrastructure. DSRC itself is direct short radio. So I cannot talk to a backend server. I cannot talk to, let's say, a security server in the backend or a map server or any other database, right? I am limited by a range of a few hundred meters, and I am dependent on a roadside unit or some infrastructure device to be able to provide all of these kinds of services. Now, then it comes down to who is going to essentially lay all these infrastructure, right? Who is responsible for it? Is it the road operators? Is it the government? Is it every state is going to do something different? Is it going to be privatized, right? And then, and in the end, I mean, how does any, even if it's a government agency, right? How do they eventually monetize this? How do they recoup all the expense? So if you ask me personally, I don't believe that DSRC would be the way that we would go in India. I believe it will be CV2X. And I also not really sure if CV2X, so CV2X has two modes, right? Broadly, what's called PC5, which is the direct mode or the equivalent for DSRC. And it has a UU mode, which I'm sure everybody's familiar with, essentially talking to the mobile base station and so on. So to me, I believe that the UU mode will be the precursor and the way in which CV2X comes into vehicles, right? Because the CV2X UU mode can solve cases where I need to backhaul a lot of data, or where my OEM can also provide some kind of services, right? Whether it's map services, whether it's infotainment, it could be anything. And today you have leading chipset vendors, leading technology vendors providing both in a single form factor. So the cost of even introducing such technology is now greatly reduced, rather than going, a DSRC route where it's a separate chipset, separate hardware, and essentially, as I said, who's going to pay for it, right? So you are seeing in the West, let's say catalyst, such as NCAP regulation, essentially your car safety regulation. We keep hearing about, a 4-star rating or a 5-star rating. So you are seeing Europe, possibly US in the very near future, and China introducing regulation saying that you need to have V2X starting so-and-so year. Now, something like that can drive adoption. But if you don't have any regulation, and if you don't have a killer application, and you don't have the infrastructure, I don't really see how something like DSRC can take off. So yeah, I think that's kind of a short version of it.
Got it. So yeah, clearly you say CV2X in the UU mode. That's going to be the way forward here, right? Mr. Dewari, your perspective on the same.
Yes. So am I audible?
Yes, very much.
Yeah, thank you. Thank you very much for inviting me here. And it's 4 p.m. So wish you all a very good evening. I think both these technologies, they give vehicle an added situational awareness. So beyond what sensors provide, the LiDAR, the radar, cameras, all these are limited by the line of sight. So V2X technologies by itself, they complement these sensors by delivering a 360-degree view, which is non-line of sight awareness. Now, this fundamentally extends the vehicle's ability to see down the road, even in bad weather conditions. Now, let's talk a bit about DSRC and CV2X from a brief technology standpoint. For a long past, DSRC itself was V2X. It was seen on the roads in Japan, US, Europe, and recently CV2X2 is trying to make the cars talk. So both these technologies, they exist, and if you look at their roots, they're rooted on different base technologies. DSRC is derived from Wi-Fi. It's cost optimized. CV2X, on the other hand, it is derived from LTE. In future, it's going to be NR 5G. Now, if you look at DSRC in specific, it utilizes the IEEE 802.11p standard. That's approved amendment over 802.11. Permits low latency communication of the basic safety messages. It could be V2V, V2P, V2I, and this communication happens with transponders. They could be of two types. One is the OBUs, which are the onboard units, and the ones RSUs, which are the roadside units. It operates in the 5.9 gigahertz spectrum of radio frequency, and it's effective over short to medium distances, as Mr. Reddy also said, few hundred meters, something like 300 meters, good enough. With its low latency, high reliability, secure nature, and when I say secure, there is much more to security than just DSRC. We'll talk a little more about it later. But because of the short range that it spans, And despite the extreme weather conditions, it receives very little interference. So this nature of DSRC, technically, infrastructure, everything cost, of course, they are crucial factors, but technically this makes it an ideal solution for fast-moving vehicles. Now, what is this communication intended for? It's intended for safety alerts, safety reasons, let's say. Example, in a car that's in front, it's about to slow down and stop, it issues an alert to the car behind, or a driver who is approaching a curve too quickly gets an alert, or there could be tolls or parking payments in terms of V2I, though there is a specific school of thought when it comes to commercial usage of the DSRC, or rather in general the V2X spectrum. I'll keep that point aside for now. You look at security, there is authentication, there is an optional encryption based on asymmetric cryptography. Privacy, you may have certificates which do not contain driver identities. You may keep switching the certificates quite frequently so that the tracking becomes difficult. So DSRC has its own advantages. Now you look at CV2X from the other angle. It's based on the 3GPP LTE or 5G cellular connectivity for, again, V2V, V2P, V2I. We already discussed just now the PC5, that's the side link, the UU, which is the V2N. CV2X also uses a 5.9 gigahertz spectrum, and that's precisely the debate where the debate roots from. CV2X can communicate, if you talk about range, for a range which is more than a mile, and if I put it in multiples, it could just be 2x of that of DSRC. With two modes of CV2X, one is PC5, that's direct point-to-point, which is the counterpart of DSRC, and the other one is UU, which is via the network. The UU interface, or the UU, the network interface, this could be for the communications which are beyond the range of PC5. Where PC5 could be used for vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure, the RSUs and OPUs, they could talk directly without the need for cellular network. And UU could be fitting in where the PC5 cannot work or cannot provide value, as we just discussed. Now, one good news. Both these technologies have similarities. They work on 5.9 gigahertz. They have same message sets. They have direct radio to radio communication. They have digital signatures, radio broadcasts, the location, the speed, the direction, broadcast to all the other radios. But there is not so good news also. The DSRC and CV2X cannot talk to each other. And that's the reason why the whole question comes. This was the background of the question now. If we have to choose between this or that, because they are interoperable, which one is best suited in India? So while I respect Mr. Sridhar's view, I have a slightly different view. Rather than this or that, could there be a view of this and that? And there are a few factors that could be considered. For example, the road infrastructure, the traffic conditions, increasing number of vehicles, the road accidents, the mixed nature of our cities. So considering this, could a mixed technology, and this is just a point of view, could there be a mixed technology, DSRC plus CV2X, that may turn out to be a promising bet? So while DSRC is in consideration in India, the Department of Telecommunications is considering the spectrum for intelligent transport networks, including V2X. Currently, if you look at India, there are barely any use cases that are functioning in this band. However, with its low latency, high reliability, better coverage, DSRC may turn out to be more suitable for safety applications. While CV2X, on the other hand, which is at present with LTE, is more, it can be geared towards the non-safety applications, which do not, at least at the moment, require real-time communication. So it may turn out to be ideal for high bandwidth communication use cases, like the advanced telematics use cases, where you have HD map downloads or video conferencing. And DSRC could be for the safety, as I said. Now, there are a few trials in my information that have been done for V2X in India. There's a company named Zero Sum IT Solutions, a Japanese company that has done a few trials in the city of Ahmedabad to improve the travel times of emergency vehicles. And that's the first known instance in India where the vehicles, the cars and the traffic lights are seen talking to each other automatically. So as a school of thought, I think a hybrid approach, DSRC for safety and LTE V2X for non-safety, could be a way ahead, left to the policymakers to think upon and decide. But as a last word, in my personal opinion, humble personal opinion, I think we should consider the primary purpose of V2X, and that is saving lives. So a courageous decision is needed anchored on this fundamental purpose. And from that perspective, DSRC is proven. It can immediately start making traffic safer than to wait for a technology that certainly is promising to become stronger over time, but there's a cost of the lost time. And this cost deals directly with life and safety. So there could be a possible solution as well for a provision transition from DSRC to a future proven CV2X, considering the differences are in the radio electronics and the software stacks and applications carry pretty much similarities to a large extent.
All right, so that's you know, in favor of the hybrid approach, but I think at the same time will also be important is if we are going with DSRC, you know, the infra is also kind of you know, ramped up for that and things like that, so that the additional investments that go in also get the kind of benefits that we are talking about with the additional investment going in. Sure. Thanks a lot for sharing that perspective. I think with that, I would like to move on to Mr. Datta with the question. So, you know, the communication protocols and development of the HMI, the human-to-machine interface work in the V2X environment, does it pose challenges owing to the quantum of data that needs to be managed on a real-time basis? Or do you think that's not a challenge right now? And after your response to that, I would also like to move that question over to Mr. Reddy as well. Over to you, Mr. Reddy.
Yeah, thanks, Ashim. Thanks a lot to Rohit for making me part of this panel discussion. When it comes to the UI, I mean, again, we discussed all this while about the DSRC versus 5G NR or LTE V2X and so on. When it comes to the the user experience or user interfaces, what we see is with DSRC, currently, I mean, this is a solution where we have already seen use cases, and there are, to some extent, with Huawei Golf 8 being deployed in Europe, maybe close to 1 million vehicles with what we will see in next 1 year. And now, which means, we are talking of day one use cases with DSRC, where the UI challenge is if you really ask me, the user engagement, user experience challenge is really minimal, primarily because we are really talking of giving an alert. It could be an emergency vehicle which is coming in, and most of the times, whenever we speak of a DSRC, it's or even with CV2X right now, the information is actually a broadcast. The communication protocol which we use is based on a broadcast, wherein everyone is broadcasting, and we have a receiver, and we will receive it, and then we will throw an alert. And we are mainly focusing on day one use cases as per 5G Automotive Association as well. Now going forward, the moment we bring in 5G NR and with LTE V2X, eventually with 5G NR, with it's not just broadcast, but then we speak of a unicast and multicast, a targeted information transfer, and then we also bring in not just a typical alert specific use cases, but then we speak of a cooperative maneuvering or otherwise. I mean, again, I'm talking to with respect to what we see in Europe and other countries. This is where we see that the latency, especially to address the latencies, and then again, we spoke a lot about infrastructure and addressing the latencies of less than 1 milliseconds with mobile edge computing being hosted on these base stations to really set up an end-to-end seamless communication across a heterogeneous system. When we say heterogeneous system, different mobile network operators, as as Kubota-san has mentioned, and different regions, different OEMs. This is something is challenging, and this is where a lot of government public funded projects are also happening in Europe. This is the case in India. I mean, this is the case elsewhere. In India, we see that. I do agree with what Shantanu was saying, that we need to speak of a hybrid approach, and with hybrid approach, we really speak of addressing the level 1 use cases, and eventually speak of a transition to transition to CV2X or 5G NR when maybe 5 years, 6 years, 10 years down the line.
All right, Mr.
Thanks a lot.
Mr. Reddy, your perspective on the same as well.
Yeah. So I think Santosh kind of touched upon the main aspect, which is, the amount of data that we're talking about and the kind of HMI interface that you need really depends on the use case and the application. So if you look at day one use cases, things like blind spot warning, forward collision warning, an emergency vehicle warning, these are pretty lightweight, right? In terms of the amount of data that's required, the frequency at which it's required. It's all broadcast in nature. So you could have a slightly lossy environment and still kind of make do. So you don't really have a challenge there. And in early deployments, and perhaps even for the next many years, you're unlikely to see car automation based completely on V2X. So for now, it's going to be much more of a informational value, right? Rather than any specific action being taken on them. So this is for day one use cases. Now, when you go to what's called day 1.5 and day 2 cases and beyond, I think people have already said that, if you're looking at cooperative driving, you're looking at remote driving applications, you're looking at, some kind of level of automation being built in, map matching, object recognition. So there you really end up now offloading some of this. I guess you could look at multiple models. You could look at the vehicle itself having high enough computation to perform a lot of these or make a lot of these decisions. The other approach is, of course, can you offload some of this to the edge? And so my camera sees a lot of information. It sees complex information. It's also receiving a lot of information. Do I really need to be the one to process all of this, or can my edge actually do this? Right. And I think we are seeing a movement, at least in industry, where the edge computing kind of a model is taking more dominance. Right. Traditionally, you've had the lidars and the cameras and the radars and so on, all the sensors within a vehicle, the whole computation being done inside the vehicle. It's a single node. It takes a decision by itself. Of course, it lends itself to non-line of sight issues and so on, which V2X can solve to some extent. But when you now look at these high bandwidth kind of usages, right, there you definitely inevitably start looking at, can I offload some of this work? So I think I don't really have much more to what Santosh mentioned, which is it really depends on the use case, depends on the application, and really depends on the in some sense on the level of let's say dependence on this specific application. When I say dependence, is it just information value? Are you actually expected to take an action? Is the car going to have any kind of actuation based on this kind of information?
Got it. Sure. Thank you. Thank you, Mr. Reddy. And also, again, thank you, Mr. Datta. So, got it broadly. Yeah, it's more of use cases. And so there isn't one answer that fits all the use cases out there. It'll more have to be dealt with a case-to-case basis. But I think something slightly related to that, and I'd like to bring the question over to Mr. Solanki. So, stable network connectivity is a must for this. And we heard some of that from Kubota-san's presentation also. How, network in the tunnel going away. And, all of us have seen that many a times on our calls, network drops. So the network is not in the best of state in the country. So what are some of the learnings here, especially from, say, developed economies, and how they've been able to manage this so as to have a seamless, V2X communication or a V2V communication between vehicles?
Sure. I think before I answer, I just want to add to what Shantanu said earlier. So I work for Napino, right? We are into automotive business for last many years, like 2.5 decades. And we are working in partnership with Continental. So Continental has created something which is a combination of DSRC and CV2X. It's a chipset which basically gives you both the connectivity formats and options in a very seamless fashion. I think what Shantanu covered was very, very crucial, that you need to have a hybrid approach, understand which one will work better, or have some kind of a format to fall back when one is available and other is not. And I think some other panelists have also covered. So this aspect of different technology being available out there. So to answer your question, I think Ashim, is that before we even talk about speed and latency, I think it's about availability of the network. One thing that in the cellular world, developed economies have done well or are doing well, and I think also India, for that matter, is options of multi-IMSI profile-based telecom support, or some kind of a multi-network support in the same device. Okay, like if you have heard of the concept of MVNO, Mobile Virtual Network Operator, or VNOs, they work. What they do is they work with telecom companies and they resell their services, which is one. What I've also seen, and I worked fortunately for one of such company based in California, we basically also provide connectivity options where the network can be switched based on the speed, not the speed, the signal strength, between T-Mobile and Sprint, or I think T-Mobile and one more, if I'm forgetting. And there, I think the problem of availability of network is the most basic problem. After the network is available and the signal strength is good, the speed and latency, I think, comes with how the network has been deployed and what kind of load it can take. How does it do load balancing and other things, right? Now, what you have seen, if you have seen in the last few years, when after Jio came, they started promising very good speed, and it was really good at the start. Things have slowed down. Why? The reason is that the number of people coming on the network has increased drastically in the last few years because of the availability of lower prices and cheaper handsets, right? Now, if you map that to experience in the automotive industry and for vehicle-to-vehicle communication, I think it is at the same time, again, crucial that whether it is DSRC, V2X, or other technology that we can leverage, how can telecom companies work collaboratively and bring innovative model like MVNO into the V2X industry, where I can switch the network based on availability, signal strength, and my need. Maybe my edge device can be so intelligent, because edge intelligence is also coming up very rapidly, right? You're putting machine learning right in the edge, and car is a very good device to put that. It's pretty powerful nowadays, at least the one that we have explored. So if I have to put some kind of intelligence, I have to make sure that both the telecom side and the vehicle, when they communicate each other, and when there is a handshake happening or a latching happening, during that time, if there can be some parameter exchanged about the need of the data, whether I'm trying to communicate on a high broadband data, like a video or an image file that I'm going to process locally, or I'm talking about a much lower data rate, like in KBs for a sensor value, to give you an example, I think that will become very efficient. So telco and the OEM industry have to come together. With Continental and Napino, we have seen that communication happening with both the service provider side and the OEMs to see whether there can be some kind of collaboration to implement a technology that can work seamlessly. It's a very partnership-driven game, right? A collaboration game. You have to co-create solutions for an innovation like V2X. It's not going to happen in one silo, to be honest, right? I think you all are so experienced. You would have seen that. I've worked at Airtel and I've worked at other telecom setup, and I think I've realized that more and more partnerships are happening where technology can be implemented in a seamless way, if possible. Yeah. I don't know if I answered your question, Ashim. So sorry, but. I hope that is what you were trying to get out of this.
Yeah, understand. So, it's partnership, of course, between the OEMs and the network providers, and also more and more between the network providers and, the intelligence at the edge device. They talked about, so that wherever the network is weaker, I mean, the system has a self-correcting mechanism in place, and also, the players coming together can probably close some of these gaps together, especially the network companies.
Yeah, and just to add, dedicated bandwidth for vehicle-to-vehicle communication is important. You cannot share it with the other use cases like human-to-human communication or human-to-machine communication.
Got it. Understood. Just moving on. Yes, Mr.
Oh, I'm sorry. Did you want me to add anything there, or you wanted to move on?
No, if you want to add, please feel free. No problem.
Okay.
Yes, please.
Yeah, so I think, Vinay touched upon the case where you have, this example that Kubota-san talked about in Europe, or even here, right, where you have handoff and so on, weaker signal from, one MNO versus another. And those are definitely aspects that need to be worked out. I wanted to talk about even a much more simple case, right, where let's talk about a case where I go through areas where I don't have any service, right? I go through a tunnel, for example, or some kind of urban canyon, or there are shadows, right? Where, let's say, for 5 seconds, I don't get any LTE, 5G, no service at all. What happens then? And then again, I think it comes back to the specific application. So let's talk a little bit about one, use case, right? There's a simple application called red light violation warning. The application is very simple. I receive signal phase and timing data from my traffic controller, let's say within a 300-400 meter distance. Essentially, what does that mean? It just means I get a red light or a yellow or a green status of the light and a timer, right? How long is it going to be in this state? So let's say I get this at 20 seconds remaining, 10 seconds remaining, doesn't matter. The moment I receive it once, I have enough information to make a call. So my vehicle has enough information. Even if I lose, service, I lose the network after that. I have enough information to say, knowing my vehicle speed, knowing the distance and so on, I can make a call. Am I going to cut the red light? Will I make it safely across the intersection and so on? So that's a case where I don't necessarily rely on the network coverage or the quality of the network. And as you rightly said, Ashim, you absolutely need regulation to kind of drive bandwidth. You need to put aside frequency spectrum, right? You need to regulate it. It needs to be licensed. You can't have anybody else kind of interfering in that spectrum. So at the basic, you're absolute. That's a basic requirement.
Yeah. Thanks for adding that perspective. All right. Moving on from this, and we were talking about the bandwidths. I think the other part, and where I would request Mr. Datta to share his perspective, is do we also need a sort of a common industry-wide standard to make V2X a success? And maybe that standard needs to be developed and implemented. If you agree with that thought, then what do you think are the areas that need to be standardized so as to make V2X a success? I think we can't hear you, Mr. Datta.
Sorry, can you hear me now?
Yeah, now we can hear you.
So whenever we speak of a V2X or a penetration, standardization is always essential. And that precisely is what 3GPP is trying to do. DSRC as a standard, it's a very robust specification for sure, but it's not evolving as such, especially when we speak of an autonomous driving and enhanced safety specific requirements and so on. So that way the standardization, especially on the lower layers, whenever I say lower layers, we're talking of an interfaces, we're talking of an handovers from one cell to another cell, we're talking of a roaming. All of these are already being addressed by 3GPP. And with the notion that we have a bandwidth or we have a network coverage available across different regions, we could safely assume that with 3GPP, with 5G V2X, rather 5G NR coming in, this will be taken care of. But the challenge right now, which industry has to address, is on the upper layers. When we say upper layers, then it's all about how do we ensure that when we have a heterogeneous system, and this is mobility will always be heterogeneous, and no matter even with standards, that means we'll have multiple OEMs coming in, multiple intelligence functions, their own specific features bringing into a V2X or advanced driver assistance system or a 5G, eventually at L3 or L4 automation. So on upper layer, the standardization is really essential, and this is where there are enough of activities, I would say enough of consortiums, which are really trying to figure out, if we speak of a standardization with mobile edge computing, where they have to do a functional orchestration at the edge, it could be at a node station or otherwise at the vehicle. How could they actually standardize the middle layer in the vehicle as well as at the edge? Is a discussion which is currently ongoing. Of course, if we really speak of achieving the nirvana of our autonomous driving, where there is more or less no driver control and everyone is rather moving from point A to point B without any intervention, then for sure the upper layer standardization is necessary. And right now there are discussions happening at different industry bodies. It could be 5G AA or 5G car, or even for that matter MEC for auto, where they're really talking of a standardization on the upper layer. But this is a work in progress, and of course only with standardization we can achieve scales and we can achieve the homogeneous response.
All right, thank you for sharing that perspective, especially so upper layer becomes the key part. And yeah, as you rightly said, unless it's standardized, we won't get the scale. And also it ensures that whatever is developed is extremely safe for application within the country as well alongside that.
Ashim, there's one more perspective to that is,
Yes,
see,
yes,
we are talking of introduction at a certain stage with the existing standards or the protocols which are available, right? Now, imagine a scenario 10 years down the line. Now, you will have a complete mix of different vehicles with different generations of the devices sitting out there and different generations of the standards which they're following. So managing this heterogeneous mix is going to be the next bigger challenge in such an environment.
Yeah.
The backward compatibility, of course, you have to maintain that. Otherwise, as a consumer, again, I'm very focused on the consumer side, customer side, because as a customer, if I buy one generation of the vehicle and say 2 years down the line, it's not compatible with the network at all or the infrastructure at all. This is not a smartphone which I can use and throw, right?
Right.
So this is very, very important aspect to keep in mind. And that's where the segregation of the fundamentals, when I say fundamentals, foundations, the networking part of it versus the application part of it. I think Santosh brought a very important point there. How do you, what you call standardize top layer so that the compatibility remains intact for you? Okay. And over a period of time, you don't lose value in terms of reusing what investments you have done in the previous generation of technologies here.
Yep.
Yeah, certainly, yes. Yeah. So from the consumer point of view, also from the OEM point of view, so you've done something and then you build incrementally on it. Yeah, I think a very, very pertinent point there. In fact, my next question is also to you, Mr. Bachu, and that is around, are the V2X systems, and we also saw that come in the audience questions, are they also susceptible to virus and hacks, and how do you safeguard against this potential threat of, potential malicious attacks from different frame structures, routing, relaying strategies, spectrum allocation approaches that need to be worked upon so as to be able to minimize such threats? And how will this sort of, evolve alongside V2X? I mean, the sort of the whole protection against viruses and attacks. How will this sort of evolve as we evolve the V2X the infrastructure, as well as make it more and more widespread in the country?
Yeah, sure. So as you're saying, the entire solution is around two major aspects. One is on the RF part. Second is on the software part. So, and both are, we have seen they are prone to hacks and they are prone to attacks. And when you talk of specifically viruses in the V2X environment, perhaps they may not be existing today in the form of a standard viruses or Trojans, what you find on the PC world or the Windows world kind of a thing. But I think going further in terms of the vulnerability to attacks, especially from hackers' point of view, this is very huge. And I think that's where the 3GPP standards and things like that are trying to contain that, how robust it can be made. And as fundamentally in terms of cybersecurity, the three key things, which are the CIA, which is the confidentiality, right, the integrity and the availability part of it. These three can be compromised on any RF kind of a channels which is there. Now imagine a situation where in a kind of a dense network where vehicles are talking to each other or talking to infrastructure, somebody comes up with kind of a, it's called an illusion attack, right? There are not really vehicles around, but somebody is spoofing that, saying that there are so many vehicles and then creating an illusion that there is a lot of traffic and then asking you to divert from there, okay? And this has practically happened. We have seen, I think some of you would have seen this video. One guy has taken so many iPhones in a cart, 100 phones, and then switched on the Google Maps and then created an illusion on an empty road that the map shows the entire road is having a jam. Right. So this kind of a thing is possible. So that is one of the possibilities. Second thing is in terms of, say, your whole integrity of the information itself. So somebody can spoof the information, send bogus information on that, right? And then it could lead to a lot of other vulnerabilities in terms of taking meaningful decisions for specific applications, what you're talking about, use cases, right? And other thing is also in terms of impersonation aspect of it. Your whole integrity is compromised, right? Where your identity is being used by somebody else. And let us say if it is, though it is not there, if it is used for tolls extensively, somebody is taking your identity and extensively consuming your account for all the things, right? All the payments which is going to be there. And simplest form of thing is the DOS attacks, which is very standard in the cybersecurity domain, which is denial of service itself, right? You just keep on bombarding with queries and information, and this, the stations which are there on the roadside units, which are not at all recovering from that particular reply. So these are vulnerabilities which are existing today. Of course, when we talk of building an integrated systems, especially in the VANET kind of environments, vehicular networks and things like that, these aspects need to be built around, the solutions need to be found around this. And there's no one standardized way of things. So I think it's evolving. And as we see, as the technology is advancing, we'll also see the flip side of it. But if you look at larger context, instances of these can be very less, but could be fatal. So this need to be protected against, and I'm sure the industry together is working on solutions to counter these as well.
Sure. Thank you for sharing that perspective. And I think you talked about how the industry is looking at that. And maybe, I posed that question to Mr. Dhaware there. Do you think there's a role for the government also in mitigating some of these challenges? And, do you think like a national policy guideline for development and deployment of connected infrastructure, which also takes into account some of these aspects, will become equally important to look at? And related to that is another question, good instances like the one that Mr. Bachu was mentioning also probably make consumers a bit skeptical about using them, some of these solutions, some of these technologies. Like we did a survey some time back, and there were people in the car who were saying, we need functionalities to be able to switch off the system. And, it should not be in play all the time, because many times there are false alerts, many times we get distracted. So, those two, you would like to hear your perspective on that, Mr.
Right, Ashimji. A short answer, it's extremely vital. Such a national level policy regulation is extremely vital, and government's role will be significantly decisive in this. So let's understand it in a slightly reverse mode. What if there is no security framework? What may happen? While the consumers may always have this kind of an apprehension, give me a functionality to stop the functionality, like you said. Beyond that, at a mass level, we will have vehicles with security vulnerabilities running on the roads. And such vehicles will be susceptible to cyber attacks. In fact, this morning I was chatting with one of my colleagues and I said, an entire city may get hacked. Imagine the traffic at the entire city getting hacked. And there is some movie around it. I cannot recollect the name of that movie, but there is a video which shows in fiction hundreds of cars getting hacked and controlled remotely. God forbid such things don't happen. And that's the very reason why security framework is essential, because without a robust security architecture, V2X is likely to experience intrusion, false signals. They may cause accidents, traffic jams, monitoring the user's movements, spreading malware car to car. And with all this, the most affected is going to be the lower income, less informed consumers, because see, they have no framework to rely on or to feel safe with. They're just somehow buying a car which starts behaving this way. On the other hand, look at the OEMs. They will have no standard to insure them against for liability. So these attacks, the affected consumers and in turn the OEMs also, together, in turn, this may lead to uncertainty in this domain. This uncertainty by itself can affect all future focused investments, and lack of investments will further affect innovation, stagnating and endangering the entire very existence of the technology. So it's needless to mention a security framework, therefore, is crucially inevitable. Now, looking at the system at the core, there is nothing called unhackable code or 100% secure software and systems. If anybody says my system is 100% secure, that person is lying for sure. In a connected vehicle, if you look at a vehicle which has more than 100 electronic car control units, small car computers, these connected vehicles are already susceptible to various security attacks. Plentiful demonstrations have already happened on it. Remotely, how the car's control has been taken and the messages have been injected on the CAN network. Now, V2X further increases this attack surface. Now, while OEMs claim that the infotainment and the critical functions on the CAN network are air-gapped, it seems this is not the case for all the vehicles. Now, further to this, these vehicle systems have inevitable interdependencies. You cannot, you may want to segment the network, but you cannot completely avoid the interdependencies. Now, V2X may further increase these interdependencies because they want to give value through the functions, the features they want to bring in. So all this could lead to various types of attacks. I'm not going to those details. We've already covered deception attacks, the DOS attacks, cryptographic exploitations, malware exploitations. But what does this all lead us to? This will cause issues of life and safety. Once again, I come back to the fundamental point, life and safety, for which all this has begun. And such issues cannot be left to the market, because these vulnerabilities are not standard. There is no standardization in vulnerabilities. Every car has different systems, different software makes, different architectures. The vulnerabilities are also different in various cars. So if you look at it from the buyer standpoint, and I really agree from the consumer standpoint that one of our friends brought in, I think Mr. Datta, it's important for the buyer to ascertain the security in the car that they want to buy. How does the buyer do this? So if you look at all this, there is a significantly crucial need for governance and compliance so that customers can make informed decisions. And you see, vehicle security, why not? It should become as trustworthy as swiping a debit card at an arbitrary point of sales machine. You go to any shopping mall, you don't think twice before swiping a card. You feel that peace of mind. So why not with vehicle security? So the role of government bodies becomes absolutely crucial here. They need to create a security framework, and it's very much possible. So I think policymakers need to build on top of existing security frameworks like that for the payment card industry. And some crucial considerations for these, they could be in lines of secure architecture for the embedded systems, like secure flashing, secure boot up, secure debugging, hardware, root of trust, protecting the stack overflow, segmenting the network well between the mission critical systems and the convenience systems, enabling cryptography inside the car network. Inside the car network, even when you deal with external communications, why not secure them as well through secure gateways, firewalls, intrusion detection systems, intrusion prevention systems, do regular penetration testing. And while all these security themes are in place, I think even the software architectures need to inbuild some level of policy making in the software, because vehicle networks, they have a fixed, at least a deterministic pattern of message communication. Take an example, why does a Bluetooth stack need to talk on CAN, the controller area network? There is no great deal of a reason. So if the software applications, the stacks inculcate these policies to disallow certain malicious actions, that could also be an added advantage. And a while ago, as I mentioned, commercial traffic, that should be, in my opinion, disallowed on the V2X spectrum, because that's going to only increase the risk of security. First, you have these whole lot of problems to solve, which deal with safety. Then we introduce the financial and the rest of the issues as well. Because the main purpose, again and again, is life and safety, not monetization. And I think the standards should also promote the defense in-depth layered defensive structure. So even if you get an access, you compromise the initial level of the access, the attack should still not be realized. Just like how you have the border security force, and then you have the army battalions, and finally the special forces. So I think it's extremely crucial that government bodies release and mandate robust security architectures that the OEM should comply to, enforce it. And the security measures should also be made transparent to the consumers so that they can make informed decisions. And while all this happens, it is, I think, prudent to anticipate some anti-schools of thought and be prepared, not forgetting standards guard consumers, consumers guard adoption of new features. You go by the theory of associativity, standards will guard the adoption of new features. We want V2X. So I think working in a more secure manner is in mutual interest of the industry and the consumers. Ashim.
I think also becomes one of the foundations, to build this up, just like standardization. And really the cybersecurity framework from the government also becomes one of the key cornerstones for that. So yeah, thanks a lot for sharing that perspective. With that, I come to one final question, and I think you also touched upon that a little bit. And first, I would like to pose it to Mr. Reddy. So, with V2X and 5G, how will the revenue landscape also change for OEMs? I mean, would there be additional avenues or services that become possible, which could be monetized out there? And maybe would also request a short perspective from, Mr. Solanki and Mr. Datta also on that.
Sure, Ashram. So absolutely. I mean, we are actually working a lot with MNOs and automotive OEMs in the West. But we've also recently started this conversation with MNOs here in India. Right. And of course, the use cases and the first applications are likely to be a little different, right? I mean, you need to adapt to the local situation. So in the West, I mean, we are seeing applications or interest from MNOs and OEMs for applications such as, remote parking or automated parking, of course, safety, pedestrian safety, inclusive of pedestrian or what we call vulnerable road users, could be cyclists, two-wheelers, pedestrians, and so on, right? But of course, it's extending to, areas such as touchless payment, right? I mean, from a tolling perspective, where, setting up a gantry, setting up enforcement for tolling is much more expensive in places in the West. Outside that, when you look at from a pure OEM perspective, you already have a multitude of sensors today, right? You have radars, lidars, cars adopting, the new age cars adopting a lot of this. But this sensing, right, is all node based. Now I sense this, sense my surrounding, I take action. But why not be able to somehow share that with other cars as well, right? And that's where, if you see somebody like Tesla is already doing that, right? They already backhaul some of this back to their own servers, analyze it, and kind of feed this data back to other cars within their own fleet, other Tesla cars, right, within that vicinity. Okay, I have a traffic jam here, I may have a lane closure, and so on and so forth. Right there, you have a way to monetize, right? I mean, think of a parallel, for example, like a company like here, or a consortium, the Nokia consortium here for HD maps. Similarly, you could have companies here aggregating this kind of sensor information so that it can be shared across OEMs, right? I mean, it doesn't have to be limited to a GM or a Ford or a Maruti or anybody, right? It could be provided as a service to anybody who subscribes. So this is one aspect. The second thing is coming to India. To us, of course, we're still in an early stage, but one, let's say, area that seems to be of interest, at least right now, again, as I said, maybe in 6 months, I might give you a different story, but based on the conversations we had so far, the captive kind of use cases. So what do I mean by that? Private campuses, airports, security within the airport, right? Automotive security within the airport, large warehouses, right? Of course, it may not be automotive fully in nature. Shipping docks. We're seeing applications of remote crane usage, right? How do I unload and load while I also have a lot of pedestrian traffic? How do I make this safe? I mean, can I equip pedestrians with 5G or any V2X sensors so that these drivers in these huge machines, right, are made aware that there is somebody close by? So we are seeing interest here in India, definitely in private campus use cases. Of course, I don't have a specific use case to tell you right now to say this is how 5G and OEMs are going to come in, right, to monetize. But hopefully in the next few months, next year, we would have much more of that.
Sure, thanks. So private campus use case is one area that you say. So, Mr. Datta, your perspective.
Okay, I mean, just to give you a perspective, now normally when we speak of entire mobility value chain, we have OEM, meanwhile, is setting up the instrument to really set up, to enable mobility. This has been the typical revenue generation model right now. And with connectivity, even doesn't matter 5G or V2X, but then with connectivity being part of, say, our entire vehicle life cycle, as well as also with the consumer, considering car as a third living space, a personal companion, some call it as a smartphone on wheels. What we see is now everyone in the industry, it could be who is down the supply chain, it could be tier 1s, tier 2s, or otherwise the mobile network operators or OEMs, or otherwise, eventually the mobility solution providers, it could be Uber, Solas, or route optimization providers or a parking solution providers, all of them want to be pitching in the game. And if you really look at, I mean, the typical revenue generation model was tier 1s, OEMs were relevant until there is a transaction wherein the asset is handed over to the end user. But this, I would say, is no more going to be same with connectivity bringing in, no matter 4G, 5G or V2X, because everyone wants to figure out how could they actually monetize based on how this personal companion, what we call it as a car, is being used, and how could we actually be relevant with the end user throughout the vehicle life cycle and throughout vehicle usage cycle. So which apparently means OEMs are trying to capture the data and trying to see what values they can actually bring in. And of course, same is with tier ones to see how could they be relevant in the B2B space, if not B2C, because of course, it's not easy to crack the B2C space, or maybe B2B space is where tier ones are typically used to. So the way now the transactions or a value exchange happens is going to be different. But this is on one side where we are still talking of a 4G connectivity and where there's no standardization, no regulation, and so on being available right now. But if you really take 5G, V2X, and standardization 10 years, perhaps 15 years down the line, the technology will be democratized. And with electrification being part of this, being part of this, the key mega trend which is going to transform the mobility, what we see is the technology and the manufacturing is going to be democratized, and revenues are being made in software and besides also in setting up some of these associated use cases and applications for the OEM or anyone who is meanwhile able to contribute to the technology. And one key aspect, one bottom line, which we always need to keep in mind, compared to smartphones, in automotive world, the functional safety as well as the security is of a paramount importance. And this is where we see the OEMs and tier ones with their domain expertise still being relevant and still making a difference. And there is also another layer, which is about UX layer and infotainment layer, where technology will be democratized and we will see a lot of solutions coming in. So the business models for sure are going to evolve into different models like SaaS, SAP, or it could be providing security as a service. It could be anything. So mobility as a service, which we already know. So the business models will gonna transform with 5G V2X pitching in. But we need to look at in what horizon this will eventually happen. Is it going to be 10 years, 15 years? Is where we'll see this being completely revolutionized. Thank you.
Thank you for that perspective. Finally, Mr. Salanki, you want to add anything else to that?
Yeah, sure. I think this is a very interesting topic. So now we are talking about money. So I'm very curious because making monetizing data and making ROI-friendly technology should be the end goal. So data monetization in automotive is very, very interesting. Like, let me tell you, because I've actually researched this quite a lot, and there is a very innovative model that was started by a company in Israel, Autonomo, OTONOMO. They actually started working with the European car makers and OEMs to help them monetize their data by taking the data from the connected car, massaging it, anonymizing it, which is very important, filtering it, and then giving the data back to the ecosystem. Ecosystem means a car, when you make a car, it's a huge ecosystem, right? It's an ocean of so many players coming together. Spare parts company, distributors, supply chain, insurance company, etc., etc. There are so many of them. And what they did very well is they worked with only 4 or 5 luxury brand maker in European market. And they created this solution where they monetize the data and give a rev share back to the OEM. And they also send the right data to the right stakeholder, right? And after that, if you see what has evolved recently is different business models, right? For example, when we talk about V2X, one of the critical pieces we have been talking is safety of the driver and the automotive, right? In order to reduce the rate of accidents. And what does it impact the most? One of the most player is insurance company, service provider, right? If there are more and more accidents. So can an insurance service provider get some information from this V2X system or a connected automotive system, which can help to evolve pay as you go or usage-based insurance or other models? It has been already there in US for last 10, 15 years, right? You plug a device in your car, you run for 6 months, and the insurance company give you some discounts if you're a good driver. You drive only in the city, you drive less kilometer, you don't speed up, etc. Some things are there already. Some things are evolving efficiently as we speak. So data monetization for V2X or data or any connected data, I think there are many use cases. As tier 1 ODM here in the industry in automotive, what we are realizing that a lot of our customers are coming back to us. And we are also thinking that whenever we make these different components and part for our automotive customer, both 4-wheeler and 2-wheeler, can we make them connected? Can we capture the data? Of course, with all these concerns around security and data privacy or data management, we are seeing this inputs coming from the OEM back to us that earlier, if you go 10 years back, they were not bothered about a mechanical or a mechatronic component being connected. But now it's not just the instrument cluster that is getting connected to the network with some technology, like let's say Bluetooth talking to my phone, but even the components inside. For example, in EV, battery definitely need to have a solution like battery management, right? But now these OEMs are also talking about connecting the DC to DC motors or the electronic grips to the ECU in the car and then capturing some data remotely. Okay, and the reason is not just because it will only help them to make a better car or a better vehicle, two-wheeler in the next, because that gives them the data. But I think they are thinking about this data monetization model. Every OEM wants to say that how can I reduce my cost and can I capture this data? Of course, with conjunction to the right to have the data. Like if you look at GDPR, right? As a driver, as a consumer of the vehicle, I need to allow that data to be transferred back to the OEM, okay? Because it's my right to privacy and right to being forgotten. So I think, Ashim, this is a very important, maybe we need a conference on data monetization, Rohit, because it's a very interesting topic. It's a very crucial at this juncture because the technology has to become feasible. And I think Shantanu, Mr. Santosh, Sridhar are talking about evolution of technology and becoming safer. But ultimately, if there is no one ready to pay for it, either from their pocket or from a consumer pocket, it's not going to become feasible, right? IoT has not evolved for many years, but now it is catching up because people are forced to adopt IoT. And the same should happen to ideally to V2X, V2V, where either there are those kind of use cases which are like the leading the tech industry into it, or OEM finds some kind of an advantage and the other ecosystem player like supply part, maintenance company, insurance service provider, etc., to say, I'm getting some benefit out of this connected technology. So let's invest more into it and make it cheaper for the end consumer to leverage this technology. I think Tesla is doing an amazing job in that. Their car is or an experience, right? It's not an automotive, a medium of transport. And we talk about that. And they have done very well with making so many different parameters in the car software enabled. I don't know how secure it is, by the way, sorry. And somebody was talking about Die Hard 4 or a city being hacked and a car being hacked. So I don't know about the security in Tesla, but I think from a customer experience, it has been superb. I think, yeah, I think I'm very interested, Rohit, if you set up something on data monetization, that would be amazing. Yeah. Thank you.
Sure. Thank you. Thank you for that perspective. Certainly, yeah, there's a lot to discover. There's some calls for another conference on that, but I just wanted to touch upon that as the final question. Also, Rohit tells me to take one or two audience questions. So yeah, anyone can answer that, depending on whichever you feel is right.
We'll just limit it to one or two questions because most of them have been answered anyway. And I think we've overshot.
Right. Yeah, we was there on the brake seals and things like that. I'll connect with the data discussion what we had. So typically in the vehicle, if you're sensorizing the various different components which are there, right? So there's a lot of value which can come in terms of information coming in. And that data, if it's provided to the specific supplier saying that how the wear and tear of the particular component is, whether it is a piston cylinder, whether it is a brake shoe, what is there. So they can really benefit from that. And that is a power what we are looking at, the kind of data aggregation systems possible out of the V2X scenarios here.
Sure. And thanks for that. So most of the questions have been answered, but I noticed one by Mayank Shukla who talks about that, we know bad weather affects the P2P communication. So will it also affect V2V communication in 5G? And if yes, will it undergo any extreme weather environmental testing? I realize you guys touched upon, losing of signal and all of that when it came to a tunnel. I don't know if that answered this or if anybody would like to add more, to this query.
I can add something there.
Sure.
Actually, if you look at a simple Google search would lead you to a Qualcomm white paper, or I shouldn't even say a white paper, but a slide deck, if you will, of results based on the CV2X testing in different environmental conditions, as well as with congestion and so on. So I don't remember the summary, but I believe overall, I mean, Shantanu may disagree here, but at least the CV2X, lobby, if you will, right, completely believes that it's, as robust or actually more, given the SNR advantages that it brings over DSRC. So does that really answer the question? I mean, is it reliable under any weather? I don't have an answer to that, but there is definitely information out there.
Okay, great. Ashim, would you like to ask the last question and then we can end this, or maybe you can sum up the session if you want, and then I can say the goodbyes.
I think we've already covered most of the questions that were there. So I think,
sure.
We'd really like to thank all the panelists for, having shared a very detailed perspective on all the aspects of connected vehicles, how 5G is going to impact, the need for standardization, need for security, how this could be monetized, what are the different technology options that we could talk about going into the future, and also, taking into account, some of the challenges that exist today and how we could tide over those also. So I think, we've had a wealth of information get generated through this webinar today, and I would also like to thank the audience we can't see them, but we've been a very patient audience asking their questions. That means, listening very intently to this. So thank you. And also thanks to you, Rohit, for, organizing this.
Okay, great. So I'll just quickly, end the session by just saying a quick, thank you to everybody, for joining today. I hope you enjoyed the session and found it useful. Like Ashim said, we really want to thank the wonderful audience for their, all the queries and their, we overstretched by 10-15 minutes, so I apologize. And I also wanted to thank our speaker group for taking out the time for the busy schedule for this. I thank you so much for your time. And lastly, our session partner, Anritsu Corporation, for supporting this session. And thank you all for joining us once again. And we will see you next for our upcoming session on autonomous, connected and electric vehicles at 4 p.m. on 19th August. So in the meantime, here is a goodbye from all of us. Thank you so much.
Thank you.
Bye.
Thanks.